Hello, this is section 3.4, which is about the chain rule. So in this section, we will we'll see how to apply the chain rule to compute the derivative of function. For example, capital F of x is equal to root x squared plus 1. This is composition of two functions. So first thing, when you have to apply the chain rule, think about the composition. That means if you have a function capital F, then find the small f composed with small g, which makes this identity true. Then we will see how to make the derivative of that. In this example, f will be square root of u, and g will be x squared plus 1. Make sure that this composition is true. Okay, now the rule of the chain rule is the following. When we want to compute the derivative of capital F, then first compute the derivative f prime, apply it on the point g of x, then multiply by g prime of x. Okay, so it's like in general, you will write f of x equal, then f prime equal, g of x equal, g prime equal. Then you will apply these in this point, and then multiply by g prime. That's the process of the chain rule. For this example, I will take, so f of x is equal to root x, g of x is equal to x squared plus 1. Make sure that my composition is true. Capital F is equal to f composed with g, so that's true. Then I will compute the derivative. F prime of x is equal to, this is square root of x, so the derivative of square root is 1 over 2 root x, because square root x, you can see it like x power half. Then we apply the rule of power. Here, the derivative of g prime, the derivative of g is 3 prime equal to 2x, and the derivative of 1 is 0. Okay, now you will apply this quantity, but instead of this x, you will put all this. Okay, then you multiply by what it is in g prime. So capital F prime will be equal to 1 over 2 root x squared plus 1 times 2x. After simplification by 2, I will get x over root x squared plus 1. Okay, so that's the derivative by application of the chain rule. Look at this, try and check. I will choose small f of x, which is square root again here, and g of x is equal to x squared minus 7x. Then computation of derivative. This is 1 over 2 root x. I would suggest that you remember this derivative of square root of x, since it is basic function. And then g prime of x will be equal to 2x minus 7. Okay, since the derivative of x squared is 2x, the derivative of minus 7x is minus 7. So here I will apply these. Instead of x, I will put this quantity here and then multiply by this. So f prime of x will be equal to 1 over 2 root x squared minus 7x multiplied by 2x minus 7. I write it between parentheses since it is a difference of 2 terms. Then we don't have simplification though, so I will let the result like that. Another example of the chain rule is the following. So again, I will choose for a f of x and g of x to make the composition true. F of x is sine x composed with x squared. So the derivative of f is equal to cosine x, and the derivative of g is equal to 2x. Then the application will give cosine x squared times 2x, and that's the derivative. For b, you will choose f of x equal to x squared and g of x equal to sine x. You see the difference between example 1 and 2. Huh? The choice of f and g is very important. So f prime of x is equal to 2x, and g prime of x is equal to cosine x. And you will see that the derivative will be different than the one in A. So it will be equal to 2 times the point g of x, so sine x, multiplied by cosine x. It's totally different than this one here. Okay. By the way, the 2 sine x cosine x, you can write it sine 2x by using the definition of double angle in the trigonometry. Now, for the try and check, I will choose f of x is equal to square root x, phi of x is equal to cosine x. And now the derivative of f is equal to 1 over 2 root x. The derivative of g will be equal to minus sine x. Okay, so the application of the chain rule will give f prime of x equal to 1 over 2 root cosine x multiplied by minus sine x. Okay, now the chain rule, a particular case for the chain rule. And now remember that when you have a function which is powered by a number, like for example, x squared plus 1 power 5, okay? You don't need here to write f and g and f prime, g prime. Just apply the rule, the power rule in the chain rule, okay? So here it's like u of x powered by 5. What is the derivative in this case? It's like the power in general. So you put 5 u of x, 5 minus 1, which is 4. But here the chain rule is there is a multiplication by u prime. That's the difference with the power when it is powered of the variable, power of the variable x instead of the function. So this is the rule when we have a power of a function. So you don't need to write the details of the composition, just write the formula like that. Okay, like this example, you see, I won't write f and g. I will just write y prime, the derivative, which is equal to 100, the power in front, and then the function x cubed minus 1 powered by 100 minus 1 times u prime, that means times the derivative of x cubed minus 1, which is 3x squared. That's it, because the derivative of minus 1 is 0. So in simplified form, it will be 300 x squared times x cubed minus 1 power 99. The try and check example here. So y prime is equal to 3 times 5 minus x power 4 power 3 minus 1, which is 2, but times the derivative of what it is inside, which is minus 4 x cubed in abstract form. So it's minus 12 x cubed times 5 minus x4 power 2. Look at this example. It's also powered function powered by a number. So again here, I will transform the function first. I will write it x squared plus x plus 1 power minus 1 over 3. This form will allow me to apply the power rule in the chain rule. So f prime of x will be equal to minus 1 over 3, x squared plus x plus 1, minus 1 over 3 minus 1, that's minus 4 over 3, times the derivative of what it is inside, which is 2x plus 1. And you can let the result like that. Sometimes we write this negative power in the denominator, so it will be 3 cube root of x squared plus x plus 1 power 4. This is another writing of the derivative. Okay, here try and check example. So I will directly change the function and then apply the power rule in the chain rule. So f of x is equal to ex minus 1 powered by minus 1 over 3, because cube root is 1 over 3, but it is in the denominator. So when it is in the numerator, it will be minus 1 over 3. Now I will differentiate. So it's minus 1 over 3 ex minus 1. Minus 1 over 3 minus 1, that means minus 4 over 3, but times the derivative of the function inside the power. So it is ex, and the derivative of minus 1 is 0. So we can let it like that, or write it something like that. Cube root of ex minus 1 power 4. Okay. Again, another derivative. And here I will use the power rule in the chain rule. So it is equal to 9 times t minus 2 over 2t plus 1, 9 minus 1, 8, times t minus 2 over 2t plus 1 derivative. And I will not put the computation of this derivative, since it will need some steps. So I will work on it separately. So t minus 2 over 2t plus 1 prime. This is quotient rule. So it's over 2t plus 1 squared. And in the numerator, derivative of t minus 2 is 1, multiplied by 2t plus 1, the one in the denominator without derivative, then minus t minus 2 without derivative, times the derivative of 2t plus 1, which is 2. And now I will expand the numerator. You don't expand the denominator, keep it like that. Then you will have 2t plus 1 minus 2t plus 4. So 2t minus 2t and 1 plus 4, this is 5 over 2t plus 1 squared. This result, you will plug it here. So you will have at the final g prime of t is equal to 9 t minus 2 over 2t plus 1 over 8 times 5 over 2t plus 1 squared. I can write it differently, this one. There is 9 times 5, this is 45. I can separate the powers, so t minus 2 power 8, but in the denominator I will have 2t plus 1 power 8 times 2t plus 1 power 2. So this is 2t plus 1 power 10. Okay, and that's the final answer here for the derivative. Okay. So 45 here. Good. So I'll just remove here. And here again, another power application. So in the try and check, h prime of t will be equal to 3 over 2 t minus 1 over t. 3 over 2 minus 1, that's half times the derivative of t minus 1 over t prime. And I will compute this by separately. So this is prime. This is in fact the same thing as t minus 1 prime. It's better to write it like that since it is power now. It's easy to differentiate. So it is equal to 1 minus 1, that's plus t minus 2. Okay, so somehow it's 1 plus 1 over t squared. Plug this in the result. So h prime of t is equal to 3 over 2 t minus 1 over t half over half times 1 plus 1 over t squared. And that's the result. Okay. Now I will use also the power rule in the chain rule for this product of function. So it's like we apply first the product and then the power rule in the chain. So by application of the product rule, I will have y prime equal to the first one derivative. It's like this is your f of x and g of x, okay? So the derivative of the first one, it is 5, 2x plus 1 power 4, but don't forget the chain rule. So times the derivative of 2x plus 1, which is 2, times the second function without derivative. So x cubed minus x1 plus 1 power 4 plus 2x plus 1 power 5 without derivative. And then I will differentiate the second function. So 4 times x cubed minus x plus 1 power 4 minus 1, which is 3, times the derivative of the function inside. So it's 3x squared minus 1. Okay, so you can write it like you take a common factor here, and I suggest all the time that common factor, you take the lowest power. Okay, so for 2x plus 1 here and here, the lowest power is 4. So I will take 4. But start with the numbers. So here you have 2 and 4 here. You can take 2 common factors. So 2 common factor, or the first term, sorry, not this one. We need to continue with the common factor. Okay, so here, as I said, I will take the common factor between these and this, which is 2x plus 1 power 4, the lowest one. Okay, then there is this and this. The lowest one is x cubed minus x plus 1 power 3. Then I will open the remaining terms. So from the first part, I will have 5 times x cubed minus x plus 1. And plus, from the second one, 2 and times 2x plus 1. Don't forget this term, times 3x squared minus 1. You need to expand what it is inside the brackets to continue the computation. So it's equal to 2x plus 1 power 4 times x cubed minus x plus 1 power 3. And now I will expand. So it's 5x cubed minus 5x plus 5. And then the second part to be expanded, we have 4 terms multiplied by these 2. So I will expand like that. Okay, 2x times 3x squared, that means 6x cubed multiplied by 2, so 12x cubed. Then 2x multiplied by -1 minus 2x multiplied by 2 minus 4x. Then we continue. Plus 6x squared minus 2. Okay, so put the x cubed together and the x squared together, the like terms in general together. So I will continue here. Between brackets, I will just repeat or compute what it is inside here to write it in this part. Okay, don't forget the remaining here terms. So I will have 17x cubed plus 6x squared and minus 9x and plus 3. That's, if there is no mistake, this is the term between the brackets multiplied by this part here. Okay, let's continue with the chain rule. So here, another application of the chain rule involving the power rule. Here I would suggest to rewrite the function as r squared, although you can work with the quotient rule, but it is better, in my opinion, to work with this form, 2r plus 1 power minus 5. So it's much better like that. And I will differentiate. It will give 3r squared minus 1 power 2 times 2r times the second function without derivative, then plus r squared minus 1 cubed times minus 5 times 2r plus 1 power minus 6, because minus 5 minus 1, it will give minus 6, times 2 the derivative like u prime. Okay, now I will take the lowest, the common factors and the lowest exponents. So I have 3 and here minus 5 and 2. So no common factor for numbers, but I have r squared minus 1 power 2. This is one of the common factors. And then between minus 5 for 2r plus 1 and minus 6, I will take the lowest one, which is 2r plus 1 minus power minus 6. I will open the brackets and then, sorry, there is 2 here. There is 2 like common factor. You can see very well here. So 2 and these 2. Okay, so I will take 2 as common factor also. And then I will put 3 times, since I put here minus 6, so it will give 2r plus 1 power 1 to make it minus 5. Okay, then did I put everything here? There is r, so I put it here, 3r times 2r plus 1, and then everything is the plus. Now there is, in fact, it's minus if you want. I would say it's minus. Since we have minus 5, so it's minus 5 times r squared minus 1. That's it, because we took 2r plus 1 minus 6, sorry. So I need just to compute between the brackets. So it's equal to 2r squared minus 1 squared times 2r plus 1 minus 6, and between brackets 6r squared plus 3r minus 5r squared plus 5, since there is minus here in front of the expansion. Okay, so in total I will have r squared plus 3r plus 5 multiplied by 2r squared minus 1 squared times 2r plus 1 power minus 6. So this is the derivative. Okay. Another application of the chain rule here, we don't have the power of a function, so I will return to write the f and g, the composition. So f of x is equal to ex, g of x is equal to sine x. Like that, I have the composition. Then I will compute the derivative, x for ex, and g prime of x is cosine x. So y prime will be equal to e applied at this point, so e sine x multiplied by cosine x, which is outside of the exponential function. Another application of the chain rule, so f of x is equal to ex again here, g of x is equal to x squared minus x. The derivative of ex is the same, and derivative of g prime of x is 2x minus 1. So y prime will be e x squared minus x multiplied by 2x minus 1. Now the chain rule applied to many compositions, at least 3, let's say. The same principle will apply. So again here for a composition of 3 functions, the same principle. I will write for you how to deal with this situation. You will write, of course, y is f y is equal to f composite with g composite with h. So you see that you have 3 functions. So you will write, as usual, f of x equal, then f prime of x, g of x equal, then g prime of x, and h of x equal, then h prime of x. Okay, so if you want to compute u prime, you will do the following. Take this function, and instead of x, you will put g composite with h. Then multiplied by this function applied at h of x. And last, you will multiply by h prime. Okay, so the u prime will be equal to f prime of g of h of x multiplied by g prime of h of x multiplied by h prime. That's the composition of 3 functions. Look at this situation. So I will choose my function here. Since I have f here, I will choose g first, and then h, and then let's say k. In the way that f will be g composite with h composite with k. Okay, g of x is sine x. H of x is cosine x. K of x is tan x. And now the derivative of g, derivative of sine is cosine x. Derivative of h prime is minus sine x. And derivative of tan is equal to secant squared x. So in total, I will have f prime of x equal to, remember what I did before. So the cosine will be taken at both these composed with this. So cosine of tan multiplied by the second one. This taken at this. So minus sine of tan x. And multiplied by the last one, which is secant squared. So that's the final answer. You can put the minus in the beginning, but it's fine to let it like that. Okay. So here the try and check. I will choose J, H, and K. J is the square. So x squared. H is sine x. And K is cosine x. In the way that when you do the composition, you will find exactly the f function. So here I will have g prime equal to 2x, h prime equal to cosine x, and k prime equal to minus sine x. And now the chain rule, so it's 2 sine of cosine multiplied by cosine of cosine x and multiplied by minus sine x. That's the derivative. Okay, another example here. So I will choose here f of theta, g of theta, and h of theta. Well, so this is e theta, secant theta, and 3 theta. See the composition of the three functions, and I will compute the derivative. This is the same, e theta, derivative of secant. This is equal to secant multiplied by tan, and the last one, h prime of theta, is equal to 3. So y prime, the derivative with respect to theta, is equal to e secant of 3 theta multiplied by secant. Don't forget to apply it at 3 theta times tan of 3 theta, and at the end multiplication by 3 that I will write here. Okay. The try and check again with the three functions. So f of x is equal to sine x, g of x is equal to ex, and h of x is equal to 2x. So the derivative here, f prime is cosine, g prime is ex, the derivative of ex is the same. So h prime of x is equal to 2. Then y prime is equal to cosine of e to x multiplied by e to x multiplied by 2 that I will write in the beginning. Finally, we will end with the derivative of general exponential function. That means the base is not e, it's any other number, positive, b. So the derivative of bx is equal to the same function bx, but multiplication by ln b. In particular, when B is equal to E, you will find that ln E is equal to 1. Then you will find the result that the EX prime is equal to EX. Okay, so look at this function here and be carefully of the base if the base is changing. Don't forget ln B. So the first one, g prime of x is equal to the same function since it is exponential, but multiplication by ln 2. And the second one, h of x is equal to 5x squared. Here it's not directly a power of x, so I will make it powered by an x. So if you want to make the derivative of this function, since we don't have here like the form b power x, it's not that far. So this is like chain rule because the power here is x squared. So I will differentiate h prime using the chain rule, okay? So it's like you say, okay, I will put g of x equal to 5x and kx equal to x squared. That's the composition. For this, it will give 5x ln 5. And for this, 2x. So my h prime will be 5x squared ln 5 multiplied by 2x. Okay, so be careful of this kind of composition. And look at this. This is same idea. So I will try to put composition here. F of x is 5 power x and g of x is root x. So for this, f prime will be 5 power x ln 5. And for this, g prime will be 1 over 2 root x. That gives in final y prime is equal to 5 root x times ln 5 times 1 over 2 root x. That's the final answer. And we are done with the this lecture about the chain rule. So be careful of this lecture. This is very important in computing the derivative. So try to understand and repeat the examples here. Thank you so much.